All right, you guys. So you might be asking yourself, why does Miss Jester have Unit 4, Day 4 notes pulled up when we are doing Unit 7? Okay, so the reason I have these notes pulled up is because we're basically doing the exact same thing today that we did back in Unit 4. So on this day, I'm hoping you remember that we did a little Desmos activity and we learned how adding and subtracting and multiplying our functions by certain things, like what effect that has on our parent function. So I'm putting this on the screen right now to just remind you that we learned all the vertical transformations, right? All these guys right here, right? And we know it's a vertical transformation when the C, or whatever you're looking at, anything that's outside the parentheses of the X is affecting the graph vertically. It's affecting the Y's only. And then on this side, you'll notice everything I have highlighted is inside, trapped with the X. And if you notice something that's inside with the X, that means it's affecting the X, so it's affecting the graph horizontally, right? So I'm hoping if you kind of peruse this over for just a second, just to refresh your memory, right? That if I add at the end, I shift up. If I subtract, that means I shift down. But if it's on the inside, it's the opposite of what we would think. So if it's X plus some number, then that means we're actually going left that many units, right? And if you see X minus a number, that means we're actually going right. So I'm really hoping this is starting to come back to the forefront of your mind, right? And then if we have the negatives, if I negate all the Y's, that means I'm reflecting over the X axis. And if I'm negating all the X's, that means I'm reflecting over the Y. Then we have the multipliers. If I have an A multiplier, that means I'm either vertically stretching it or I'm vertically compressing it. And if my multiplier is on the inside, then that means I'm either horizontally compressing it or I'm horizontally stretching it. Okay, and remember, this is when I did my little walking to school analogy, right? If I go twice as fast, I get there in half the time, right? Or if I walk a third of my normal pace and I'm going really slow, then that means it's going to take me 3 times longer to get there, right? So I'm going to be using all of these same concepts and analogies today, except instead of applying it to the parent linear function, we're going to be applying all these movements to the parent quadratic function. But the rules do not change, right? So that's what we're going to be talking about today. All right, so I'm going to hop out of here. I'm going to go back to our notes, for Unit 7, and here we go. All right, so Unit 7, Day 4. All right, we're going to determine transformations on the parent quadratic function. So if you don't remember, I've plotted over here the parent quadratic function, right, which is y equals x squared. All right, remember it's going through the points 0, 0, 1, 1, 2, 4, 3, 9, right? We're just squaring those values. And then all his little reflection buddies. But now we're going to take this parent function and we're going to shift it left or right or up or down. Or we might reflect it, right? And so that it opens downward. Or we might horizontally or vertically stretch or compress it, right? Which we'll talk about what that means here in just a few minutes. All right, so you'll notice this table basically looks the exact same as the one that was back in Unit 4. Except I'm not using C's and stuff. I just went ahead and put numbers in its place so we can just work with those, okay? All right, so our first one, we're gonna do all the verticals, right? Which is everything in this column, okay? So I know it's vertical when my number is outside the parentheses. Okay, here we go. I'll use blue. All right, so what does a plus 3 mean? Well, that means I shift up 3 units. Oops. Let me scooch that over. Okay. And then, of course, this minus 5 means I am shifting down 5 units. And I'm hoping we can see what that would look like, right? If I had my graph of my parent function, which, I could do right here, right? If I shift it down 5 units, right, now my parabola is going to look like this, right? Same parabola, Same width and everything, right? Just shifted down 5 units. If you want to, you can, of course, check all of these in Desmos, except you'll actually have to type in line 1, you'll have to type in f of x equals x squared. And then on line 2, you can literally just type in g of x equals f of x minus 5, that problem we just did. And then you can compare, right? When you type this in Desmos, you're telling Desmos to take f of x, which was your original parent function, and move it down 5 units, right? So you can totally type this into Desmos, but you have to know how to type it into Desmos, right? So I'm just going to put a little note right here. If you want Desmos to help you out with these problems, you have to first type in the f of x, and then you have to type in the g of x and what it's doing to the f of x function. Okay? All right, let's keep going. All right, if we negate the y, all the y's, so remember, I'm going to draw my little same kind of picture that we talked about last unit, right? We know all of our positive y's are up here and all of our negative y's are down here. So if we negate them, that means the positives go to the negatives and the negatives go to the positives. And you can clearly see what's happening is you're hopping over the x-axis, okay? So anytime you've got the negative in the front, it's negating the y's. So reflection over the x-axis, which I know that's written at the top right there, but I'm just going to write it again for good measure. All right, now we're going to do g of x equals 4f of x. Now again, if you get stumped on these, you can always go to Desmos and type in your f of x and your g of x, right? You have to type in f of x equals x squared first so that your Desmos knows what in the world you're talking about for f of x, okay? All right, so let's talk about what's happening here. If I put a 4 multiplier in the front, this basically means I'm vertically stretching it by a factor of 4. I'm making it 4 times taller, right? So this is a vertical stretch, right, by a factor of 4. Right, so I'm going to put in parentheses 4 times taller. Okay, now let's talk about what's actually happening though, because really what we want to know is how is that affecting our graph when we vertically stretch it. So imagine, here's our parent function, right? So imagine you take a hold, these are hands, by the way. Here's arms. So imagine you take hold of the ends of this parabola and you pull up, like this stays put, the vertex stays where it is, but you pull vertically up and you try to stretch it out 4 times taller than it was originally, right? And what effect is that going to have on the parabola if you stretch it 4 times its normal height? Well, I'm hoping, here, I'm just going to scooch this picture over here because I like it. I'm going to kind of put it down here. Or, yeah, I'll put it underneath here. Actually, I'm going to put it right here. Oh my goodness, I'm so indecisive. All right, so if I take my little hands and I stretch it vertically, that's going to make my graph more narrow, right? It's going to narrow my parabola. So I'm going to make sure, sorry, I'm trying to change colors here. I'm going to go here. So this is going to make my graph narrower, right? And that's what we need to know. Right? If I vertically stretch, it's going to make my parabola narrower because I'm pulling up on it, so it has no choice but to get skinnier, right? But instead of skinnier, we're going to say narrower, okay? Okay, let's talk about 1/3, right? Well, 1/3 means I'm pushing it down to 1/3 of its normal height. So this is a vertical compression by a factor of 1/3. Now, what does that mean? That means it's 1/3 its original height. So it's shorter, right? So again, I'm going to kind of do that same hands analogy, right? If I have a parabola, draw a little smaller version. Maybe, if it'll draw a nice pretty parabola for me. I'll take it. Okay, so let's say this is my parabola, right? But now my hands, right? I'm gonna use all my weight here. Those are my hands. Now I'm pushing down because I'm making it shorter. I'm making it 1/3 its original height. Now up here, right, when I pull it up, it has no choice but to get skinnier. But down here, I'm pushing it down. Well, if you push something down, it has no choice but to get fatter, right? It's gonna get wider when I push it down, okay? And so that is gonna be the effect, right? It's going to give me a wider graph. And that's the verbiage that they're gonna use on your STAR test usually. They might say vertical compression, right? But most of the time they say like what happens to the parabola, and they'll say it gets wider, okay? All right, hoping that makes sense. Come over here. Let's do horizontal transformations. And again, I know all of these are horizontal transformations because the only thing that's changing is they've put something inside the parentheses with the x. Okay, if I'm inside with the x, I'm affecting it horizontally. All right, so remember, anything you see inside the x is always the opposite of what you think is actually happening, right? So this, when I see the -4, I kind of think left 4, but no. When it's trapped inside with the parentheses, it's the opposite. So this is actually a shift right 4 units. All right, it's the opposite of what you think is happening. Okay. Then the same thing on the f of x plus 1, right? It looks like it's going right 1 because it's positive, but it's really not, right? So this is a shift left 1 unit. Okay, so those are pretty easy to remember and identify, just like what we did when we were back in Unit 4. All right, for the reflection, I just want to make sure we understand why it's a reflection over the y-axis, right? So remember, if I'm negating my x's, which is what that's saying, it says negative x, so they're telling me to take all my x's. Well, remember, all your x's exist over here. These are your positive x's, and then your negative x's exist over here. So if they want me to negate them or to swap them, then all my positive x's come over here and all my negative x's go over here. And notice what's happening is we're hopping over the y-axis, right? So that is why this is a reflection over the y-axis. Okay. Now, I don't know if you thought about this, but I'm going to kind of go back up here. If I reflect my parent function over the y-axis, here's the y-axis, is that even going to do anything? No, because my parent function is already a reflection over the y-axis because it's perfectly symmetric, right? So in this case, if I'm just reflecting the parent function over the y-axis, well, that doesn't do anything. Now, reflecting it over the x-axis, right, does something because it makes it turn upside down, right? But a reflection over the y-axis, not really going to do anything, but only if it's a parent function. All right, now let's go deal with these weird ones at the bottom. All right, so g of x equals f of 4 times x. Now remember, it's always the opposite of what you think. So over here, when we had the 4 multiplier, it looked like it was a vertical stretch. And that's kind of what it looks like over here, but that's not a stretch. That is actually a compression, a horizontal compression. All right, so if your number is bigger than 1, I'm going to write, let's write it right here. A is greater, actually it's a B, but, all right. If the number is greater than 1, then it's a horizontal compression. And it's a horizontal compression by 1/4 the reciprocal of 4. Okay, it's always the opposite or the reciprocal of what you're looking at inside the parentheses. Okay, now why is that happening? Well, again, remember my little walking to school analogy. Here, I'm going to put a little walking person just so in the notes so it can remind you, right? So let's say bleep, we're walking to school, right? Here's school. All right, if I'm walking to school, right? If I'm going 4 times my normal speed, actually, hold on. I'm going to graph a parabola. Here, let's say this is the parent function. So my parent function is my normal speed, right? If I'm going 4 times my normal speed, then I'm going to get there in a fourth of the time, right? Which is why it's a horizontal compression by 1/4. I'm going 4 times faster. So I get there in a fourth of the time, which makes this a narrower parabola. Right? It's the exact opposite than it was with the y ones on the left. Right? So if it's a big number greater than 1, then it's a compression. And then, of course, let me copy this here. These awesome illustrations I got going on here. All right, and so on the next one, right, we're doing we have 1/3, which looks like a compression, but it's not because it's inside the parentheses, so it's the opposite, right? So this is a horizontal stretch. Oh my goodness. Horizontal, I can spell, stretch by a factor of 3, because it's the reciprocal factor of 3. So notice the B is less than 1, right? When that happens, it's actually a stretch. Now, why is that happening? Well, again, I'm going to talk about the same exact walking to school analogy, right? But now I'm being very slow. I'm going 1/3 my normal speed, right? Well, if I'm walking 1/3 my normal speed, then it's going to take me much longer to get to school, right? Right, it's going to take me much longer. So naturally my graph is going to be wider because I'm going to take more time. Imagine the x-axis is time, right? So it's going to take me 3 times longer to get there, right? So it's going to make our graph wider. Okay. All right. I'm going to add A is greater than 1 over here. I forgot to write that down, so I just want to throw that in there. Right? If A is greater than 1 over here, it's a stretch. If A is less than 1, it's a compression. And then on the horizontal side over here, it's the exact opposite. All right, so pretty much this is your study sheet, right? If you get stumped on any problem, this is where you need to go, and all your answers are basically here. Okay? All right, so all we're going to do is we're just going to go through these 11 questions and write down all the transformations that are happening. That's it. Here we go. So remember, all of these f of x's that we're seeing, they're all x squareds, right? They're telling us up here that we're taking the parent quadratic function and we're just writing it in transformation form to get these new functions. Notice some of them say g of x, some say h of x, some say j. It doesn't matter, right? As long as we're changing the f of x into something else. All right, so here we go. Number 1. What does it mean if I have a -5 inside the parentheses? I'm hoping you're saying shift right 5 units. Okay. And that's it. So basically, again, you don't have to sketch a graph. I'm just going to show you. Right, if that's my parent function, 1, 2, 3, 4, 5. Now g of x is here because I'm just telling you to shift it right 5 units. Okay, so that's what my new graph would look like. All right, hopping over here. What does a +3 inside the parentheses? Well, I know it's horizontal, and anything in the parentheses is always the opposite of what you think it is. So this is a shift left 3 units. That's it, right? This is literally all y'all have to do with these problems. All right, next we've got a +5 on the outside of the parentheses, which means it's affecting it vertically because it's affecting the y's. And what you see is what you get when you're outside the parentheses. So this is a shift up 5 units. All right, and then I'm going to go over here. We've got a -3 on the outside, which means it's affecting it vertically. And like I said, what you see is what you get. So this is shift down 3 units. Again, right now we're just doing one shift at a time, right? All right, let's go to this one. Oh, this is 2. Now we're up in the game here. All right, so the +2 inside the parentheses, that means it's affecting it horizontally, and it's the opposite of what we think. So this is a shift left 2 units. But then here we have a -1 hanging off the end. So this is a shift down of 1 unit. All right, hopping over here. Looks like the only thing we have going on is a negative multiplier in front of the y, right? Because f of x is y, so we're negating the y's, which means we are reflection over the x-axis. Remember, if you need to, just sketch yourself a quick graph, like, oh, my y's are up here and down here, and I'm going to reflect them, so those go there and those go there. So you're reflecting over the x. Okay. All right, let's go to another couple here. Let's see, on this one, now I'm negating the x's, which means now I'm reflecting over the y-axis. Okay, then I have this -3 hanging off the end, which is a shift down. I know it's down because it's negative and it's outside the parentheses, which means it's affecting the y's, which run up and down. So shift down 3 units. All right, I'm hopping to number 8. Ooh, this guy's got 3, right? So it's got the negative in the front, which we just talked about right above this one, right? So if I'm negating the y's, that means a reflection over the x-axis. Then we have the +2 inside the parentheses. So this is shift left 2, because it's the opposite of what you think when you're inside. And then we have the -1 constant hanging off the end, which is a shift down 1. All right, just got a few left and we're all done. All right, this one has a 3 multiplier in the front, which means it's 3 times taller, right? So I'm going to write a couple things down here. So it's a vertical stretch by 3, which I want you to write down. But I also want you to tell me, does that make the graph narrower or wider, right? Is my parabola getting taller and skinnier, or is it getting wider and fatter? Right? So if I'm vertically stretching it by 3, remember I'm pulling it up, so he only has a natural recourse to be narrower. Right? If I pull something straight up, it has to get skinnier. Okay? All right, let's hop over here. All right, we got a couple things going on. We've got the 1/5, and we've got that -3. So let's talk about the 1/5. He's on the outside, which means he's vertical. So I automatically know I can start this with the word vertical. And it's a fraction. It's less than 1. So this is a vertical compression by 1/5, which means we are pushing this parabola down with our hands, right? It's like we're on the arrows and we're pushing it down. And if I vertically compress something downward, his only option is to get wider. Right? He has nowhere else to go but out. Okay. All right. And then, of course, we have the -3 hanging off the end, which at this point I'm hoping we'll remember that just means shift down 3 units. All right. And then our very last one, we've got 3 things happening here. Noticing they didn't do any horizontal stretches or compressions. That's except for, yeah, that's weird. Anyway, okay. So we've got three things going on. So we've got this 5/3. Now be really careful. I know it's a fraction, but remember 5/3 is technically 1 2/3. It's a number bigger than 1, right? Because it's an improper fraction, right? So even though it's a fraction, this is a vertical stretch because that value is greater than 1. So it's a vertical stretch by 5/3. So remember that means we're pulling up on the arrows. So he only has a natural reaction of getting narrower if we vertically stretch. All right, and then we have our -4 inside, which means we're going to shift right 4 because it's the opposite of what you would think. And then, of course, how many times can we see a -1 on the end? Goodness, this is shift down 1. So again, anytime you get stuck, right, remember this is your learning guide right here. Everything you need to know is written in this big box right here. Okay, so use it as your reference if you get stuck on any of the problems on your homework. Okay. All right. I hope all that makes sense. And if you have any questions, of course, you can come and see me. Bye.